the entire mountain swells, which means that the outer slopes get steeper. There are probably a succession of small earthquakes and then maybe a big earthquake that shakes loose this very steep western flank of the volcano.
Almost 1,500 cubic kilometers of earth and rock plummet into the sea. On impact, the land displaces a massive amount of water. The ocean rushes back to fill the giant gap. From this cataclysmic disturbance emerges the tsunami, heading directly for Honolulu. Estimated time to impact, 30 minutes.
This is the direction that a big tsunami would come from the Big Island.
The wave first becomes visible as it stands and breaks on a shallow bank, 40 kilometers southeast of Honolulu.
You'd see the sea rear up in front of you. It would be huge. It would rise up above you the size of a building, the size of a 10-story building.
Surging inland at up to 70 kilometers per hour, the tsunami slams Honolulu. Because the tsunami's energy stretches down to the ocean floor, this wave is not clean water, it's filled with sand, coral, and rock. Water penetrates 16 kilometers inland before being sucked back out to sea in a lethal maelstrom of wreckage. It annihilates nearly everyone and everything in its path.
Earthquakes are caused by the movement of the huge tectonic plates that continents sit on. And what happens is they come together, and one, in this case, the Pacific plate, is moving below the Japanese or Eurasian plate. Now it causes that plate to bend when it sticks there. There'll be a bit too much friction, it'll stick, pressure builds up until suddenly it's released and flick. Have a look at this. Now this is the tectonic plate that Japan is sat on, and here's the Pacific plate coming down underneath it. Now normally they want to move together at about 9 centimeters a year, but sometimes it gets stuck. And when they get stuck, the energy of them moving together gets translated to strain energy, literally flex and bend in these huge slabs of rock. Now that energy builds and builds, they're flexing and bending more and more. When they finally slip, that stored energy, all that twist and bend in the rock gets released into sudden movement, like that. As you can see, it literally flicks up, moving the ocean floor above it, which moves the ocean, causing a tsunami. So here we've got a bigger submarine version of what's going on. Now this gives a representation of what's been happening 24 kilometers below the ocean surface in the Japan Trench. Now these things work in what they call a stick-slip way. Most of the time they're stuck, but occasionally they slip, and that's what an earthquake is. So we've got it here, this is bent up here. It's full of pent-up energy, waiting to slip. Now when the slip happens, that energy gets released into the ocean, causing a series of tsunami waves, moving in both directions across the Pacific.